All right, good afternoon, everyone. Let's get started. Can you hear me well? I guess most of you know what Azure App Service is, right? That's why you're here. Or no? Yes? Maybe? All right, I did this talk, I guess, about last to last build, where I showed a bunch of tools on how to troubleshoot your application with Azure App Service and talked about a vision that we wanted to make the whole story self-service. Today we will look into a glimpse into that vision, how far we've come across as a service, and what you should be doing when bad things happen to your good apps, right? So that's the talk. Real quick about the Azure App Service. We are one of the largest service in Azure, mainly focused on web apps, mobile apps, API apps, and then there is Azure Functions, which is our serverless story. And this talk will be focusing more onto app service web apps, the Windows-based, not the Linux-based, which is still in preview, and what we've done so far to make our customers and our lives easy when things don't work well to their expectations, right? In the agenda, we'll go over the support center. I'll go over some of the scenarios that, in fact, some of them I'll be looking at right now myself. We'll walk through that. We'll look into type of issues that we try and diagnose and do a self-service for you, and go over the architecture behind this service, what powers this self-diagnostics, and we'll look at some of the tools, right? So with that, let's jump right into the demos because we have about 20 minutes. How do you get to Azure App Service Support Center? It's from the Web App Settings blade, diagnose, and solve problem. So let's see what it looks like. All right, so this is one of the web apps that I have created a scenario of a high CPU that is happening at this moment. If I were to be browsing to my web app, it is giving me several errors and things along those lines. So if you were to come to this web app and diagnose and solve problem, you will notice a couple of things right off the bat. It is telling me my app is experiencing several errors right now. And the platform seems to be healthy, right? And the way you look at that is by looking at this availability chart, where the green bar is basically showing or talking about the platform availability, which is basically some canary sites that we run alongside your web app. We keep on pinging that and see if the response is 200 okay. The platform seems to be okay, but your application is giving some sort of errors, right? And you can start looking into it by flipping the chart and say, yeah, it seems like at these times I'm seeing the blips. You can also look at the request flows and how requests has been coming. As you can see, the ones in the green are 2xx, the HTTP server errors, and how they've been correlating with the availability. The perf chart tells you the latencies. What was the latency of your requests as they start shooting up and things along those lines. And as you can see, you don't have to really look at tens of different logs and try and parse the things out of by yourself. You're combining all the logs coming from all the instances across all the region for a specific web app. The whole data is aggregated, right? So you don't have to do that yourself, and it comes up right away. So real quick, if you go back here, and what else you will see here, these are the timer slices, where we detected your app had a downtime. The one that is currently selected, it is the one where it is down at this point. So if I look at this, what it's saying, your app is unhealthy. We detected high CPU on one of the instances. You know, this app happens to be running on a one instance, and we'll see in a later scenarios there are multiple instances, but it says, yes, this guy is running at 91% CPU. This is the instant ID, and it's been having an average CPU time of 90%. So there is something wrong, right? So right off the bat, when you come in, you see, yes, the CPU for my app is causing a problem, and let me try and fix it. The quick way to look at it, I can click on this live HTTP traffic, and within 10 seconds, it should load up the live traffic aggregated of what is happening to my application at this given time. This data is about 10 seconds delay. But if you look into it, it gives you aggregation of, 6 requests came in, all 6 failings. It tells you I'm having 100% downtime, right? None of the requests are serving at this point, and things along those lines. If I go back, it gives you a suggested solution based on what we detected is the problem, and it walks you through step by step what all you can do. So first thing we notice that it is that one specific instance that's running at 90% CPU. We don't want to take the hammer and restart the whole site. Maybe we just want to restart a specific process, right? So you can try and restart W3WP process, and it's basically restarting at this point. And it'll take a few seconds, and the site will come up, and the request will come, and things along those lines, and it will take about 5 to 10 minutes for the portal to reflect with all the data to saying yes, the issue is solved or not, right? And we'll be able to see the impact into live traffic once that starts coming up, right? While we're waiting for that, let me just go over to a few other things. If this solution wouldn't work, it will come and tell you this solution hasn't worked, try the next one. And the next one we say, okay, well, try and restart your application. And this is basically taking a hammer saying, I'm going to go ahead and restart all the processes instead of this WWP and get you out of the situation. If that doesn't work, try and remote profile your application because something in your code that's doing it, but you get the point, right? This is one scenario. While the operation is happening, we'll come back to it and see if it resolved the issue, and we'll be able to see right here. I'm going to move on to second scenario. In this scenario, again, it's saying the issue is happening right now, and they have detected, as you can see, the perf availability keep on dropping down. There's a nice pattern to it, and there are different time frames. You know, if I were to say what happened here, I click on this, and it says, yes, there is an issue with the application code. We found the thread count was way too high inside your process, right? It gets you and peels the next layer of the onion, and this is the point where you say, okay, I'm suspecting the threads are way too high inside my process. Maybe I'm getting way too many requests. Maybe my threads are stuck. Something's going wrong. How do I solve that? Because this is not something you might be able to solve by restarting. Even if you restart, you solve it, the issue will come back again, right? So the suggestion and solution we provide over saying, okay, hey, go ahead and turn on application insight. It will tell you exactly how many threads are there, what is the call stack for that thread, and you go from that point on. Or you can try and do remote profile of your application, and we point to some known articles and blogs based on the pattern that we detected. Or you can take a memory dump your process and analyze by yourself and know exactly what those threads were doing and things like that, right? But again, you can see it's issues happening right now. I click on that, and you know it will all correlate nicely, right? At this point, I see there's always a spike in requests that I'm seeing when the thread counts is going up. That tells me it is related to some sort of requests increase from my application where number of threads are increasing. They're probably not executing or finishing execution as soon as they can or should have, and you know I need to troubleshoot that. Again, all of these things, if you were to start from a ground up where you're seeing my requests are slow to web app, right? Start peeling those things. It's saving you hours and hours of time in troubleshooting by having these clicking things around, right? If I were to go back here just to see if it has refreshed yet, it'll probably do it. Over here, the restart is successfully done, and you know you can look at the live traffic, and in a little bit we'll start seeing that data starts improving in some time. Right here, you see that the requests start increased. It's getting better, and now all of a sudden the red will turn into blue because now I'm starting to get success. Not all of them are failing, only 4 are failing, and when everything's backing up, it will work perfect. If I were to go back and refresh the status. In a little bit, it would basically go ahead and say, yes, the app looks healthy when the data has been refreshed back into our backend. We'll get to that in a little bit. Third scenario, you did some deployment. We found your configuration was bad, and you see the availability is completely flat. The platform looks great, but the app is completely down for the rest of the time. If I click on that, what happened here, it tells me we found high memory and one event, which is duplicate section in your web config file that is causing 5xx errors. So if I were to go and say, okay, you can scale up, or you can start looking into check your web config file by looking into Kudu. It will single sign me on to the application and show me. If I look at my web config, and I'll try and find out what the duplicate is, and it will get it from that point on. Are we doing on time? We're doing great. Okay. So I go back here, command prompt. Okay, sites, www root. I'll look at my web config, edit it, and at the end, I'll purposefully put a duplicate section right here. As you can see, the compiler section is duplicate. That's giving me errors. I'm going to go ahead and take that out, right? So it detects that I'm getting 5xx with a very specific substatus code inside the system, and it tells me that, yes, something went wrong with web config. Ask this guy to check his web config at the point. So I'm going to go ahead and save this. And in a little bit, once that's done, the site should come back up after making the check again. The data goes back to our pipeline and takes a little bit to reflect, and it will come back up in a little bit, okay? Next scenario. There's again, the availability is completely down, but the platform is up. If I look at that, it says, let me see. Yes, there's a high memory, but I also see an event log exceptions for your application that keeps on failing. The suggested solution is try and look into your event log or app insight. I click on the event log, and this is where it's going to go and grab the event logs from all the instances that the site is running on and tell me exactly what that event is giving that error, why my app keeps on failing. It's a .NET app, and right here we see the exception code, and here, begin request is where it's failing. This is where you get your dev and say, hey, try and fix the issue. So again, all these things, signals that we end up getting, we process them and try and make a meaningful suggestion based on that. Over here is the same scenario. It's a managed exception. So it is by ASP.NET. It will be swallowed by the runtime. You probably won't end up showing an event log. So we know that is a .NET exception that is swallowed by the runtime. It won't be in the event log, and we won't show you to open the event log in this case. We'll most likely ask you to scale up or here, check the app insight. There is no event log because app insight is the right way to go to find and debug those first chance exception that happen with the application. Finally, one more scenario, which is the high memory, and unfortunately, it just happened right now. But if I were to see what happened at this point, I can go back here and see what was the issue. Or here, right? And there's a unique pattern. This is, yes, CPU keeps on increasing. Your site crashed for unknown reason. You can scale up, you do remote profiling, whatever that you like. And you can start looking at the requests as yes, as the pattern keeps on coming, I'm seeing those issues, and you get the point, right? So I'm gonna go ahead, and since you'll see one thing you'll notice here, it is not asking me to restart the application, because it is root cause analysis mode, right? The issue hasn't happening right now, it happened in past. Restarting is not gonna solve the issue, so it's smart enough to understand maybe you want to scale up instead of just restarting. Maybe you want to have more instances and go from there. Okay, let's see. This should be, as against the first one, we restarted, everything's back to life. You can tell that it's working great. And hopefully the back end is refreshed, and there's always a little bit delay, but it should say the app is healthy at this point. And it tells you, yes, whatever action that you took that I asked you today, and life is back to normal, so which is a great way to go. These are some of the examples. It's not a comprehensive set of what we go after, but there's tons and tons of things that we can or are able to detect, and there's more investments coming in this space. So let me show you a little bit how this whole thing works. Here's a squiggly diagram of how we do this. The app service, in a sense, is basically a PaaS v1 offering with tons of servers in a one given stamp, right? So you're talking about one stamp is in like, if your site is hosted in West US, region 1, or stamp 1, you're looking about 1100 VM inside that stamp, and your application might be running on one of those 1100 VMs. We have hundreds of stamps per region, pretty close to 1,000 now around the world, and we get this data from your application, every single web app, from the application perspective, from the platform perspective, and we send them to all these different data sources that are within the service in a compliant way. For example, the Redis cache, it is the one that powers the live HTTP traffic that you see. There are tiny agents sitting on all this worker, a web worker where your application is running, that's accumulating the success and a failure of your requests, sending it to the Redis cache where we do the calculation on aggregation of all the requests per web app across all the region, and then start plotting the chart. And hence there's only 10-second delay. There's a platform-specific data source. It is basically where we have our live site alerts. This is me versus you scenario. If the platform is down, we have a live site, and you see there's a container availability going down. And this data comes right away from our internal monitoring, so there is no delay from the platform incidents. The platform-specific data source is basically how's the runtime doing as well. What's the CPU of the VM, what the CPU or memory of the VM, and how's our runtime, our code is doing, and things along those lines. Perf1 storage is, again, nothing but the perf counter data that goes into a cache. So this data is always refreshed within a few seconds. And then we have data from our analytics DB and configuration. So all the workers keep on pushing data to different data sources. Then we have a system that we call as a diagnostics role, where we have all these detectors. You saw the high CPU detector, high memory detector, bad config detector, single instance detector. These all go out and pull data from all these middle sources and do their analysis saying, hey, I found a match for what I wanted to detect for, and send it to the app analysis engine. All these detectors fire it together, app analysis engine is the one that makes a decision which detector gets the priority over which one, which things, it is the one that makes a decision saying, yes, this is the high CPU issue and not the back config. I want to show that as a scenario first and how we go and solve about that, right? And this is how the clients are basically connecting. All right, let me go back real quick and I'll show you some of the scenarios in a screenshots because it is difficult to replicate this live. I really don't want to do a live site to show you how this works. But if there was a platform issue, you will see the platform is unhealthy and the green is completely flat at the point. And it tells you, yes, it's a platform and the Microsoft engineers will be probably looking into it and, they try and solve that point. There is absolutely nothing you can do. So there is no real solution to provide here. Another scenario, a bad deployment. Somebody checked in a bad code, right? And that caused your app to go down, and it will detect it right off the bat, saying, hey, there's an application with an issue with an application code. Somebody had done the deployment. So we have signals that tells us the site got a deployment using web deploy or kudu or whatnot. And if we correlate that with your availability, if the availability is going down because of the deployment, it's an easy way to say, yes, it was a deployment. And the solution says, hey, use a site swap or swap the deployment back if you choose to. Finally, this is an example of a single instance bad code. So this is a site that's running on a multiple instances, but not all of them are failing. Only one instance is in a bad state and it's giving me 500 errors. Everything else is fine. So I don't want to put the hammer down and restart the whole site and take the other one out and impact the availability. I just want to go and restart the one that is specifically a problem, right? So over here it says you got 2 or 3 instances, but only this guy is showing a availability loss. Other 2 are fine. Go ahead and restart this guy and not everything else. So it is a smarts built in to the system as well. And finally, it's a high memory scenario. We can detect the high memory as well, just like how we do with the CPU. All right, we got 3 minutes. I want to quickly go over some of the other a la carte tools. It's not always that you want to use the self-service and tell you what exactly is wrong. You might want to deep dive into multiple other tools. And here's a great example. I spoke about a bunch of other tools, but in the interest of time, we'll just look into this. This one is a metrics per instance, per app. It'll take a little bit, but this is where you look at your perf counters, right? You can look at your percent memory, private bytes, IO read writes, right? ASP.NET counter, TCP. If you have multiple instances, you will have multiple instances basically here showing. Let me see if I can do it from here as well while this is coming. And you can basically flip through that and say which instance is causing what process time and whatnot. 10 minutes, 1 hour, 3 hours. You can switch to site metrics and start getting into details like, okay, well, give me the split out of 2xx, 3xx, 4xx for last 24 hours or last 1 hour per instance, right? And that's basically the aggregation you can get at the CPU memory, the network traffic, right? And over here, there's a great example. We have 3 instances, right? So if you want to start peeling the onion yourself, which one is the bad one, right? So if you go here, well, 24 hours ago, this site had 10 instances, right? Right now it has 3, but 24 hours, 10 instances. And if I click on that, any of them, I'll see, okay, well, this guy had these many errors at that time. This was the one that was in a bad state, or it's been always there, right? But you get an idea. You can start drilling into instance specific and looking into more detailed view if you choose to. The other one is a similar view, but for the app service plan. Because you might be running into an issue where your app service plan has 5 or 10 of web apps. And one web app is impacted because of the neighboring web app, which is yours own, right? And then you want to peel that onion. Okay, which is the one that's causing the issue? Is it the one that I'm looking at, or is something else? And this is where the app service plan view comes into picture, which gives you a view of the entire app service plan. But it tells me, for this guy, I got a couple of sites running here. There's a high CPU scenario and a high CPU neighbor, right? And then I can look at the neighbor seems to be good, and the CPU one, so the one that I was looking at is the one that's the culprit. It's not the neighbor, right? And things along those lines. So there are tons and tons of other tools, I recommend you play around with all of them. Provide feedback. The best way to provide feedback is go here, send a feedback. If there's a detector or a scenario that you would like us to code or haven't seen, do let us know, and then we'll basically code it. The great part about this, the system is in place. We have the data. We just have to now write the logic on what we want to detect and which scenario we are missing and which we want to go after, right? But the idea here is that cut down the troubleshooting time to find out why my web app is giving 5xx to few minutes from hours and without having you call to Microsoft support. And to get to a point in the next level where we are able to perform some of this mitigation automatically on your behalf and come and tell you, by the way, I restarted your application at 2 in the morning because I noticed the situation and I recovered it for you automatically, which you can do and configure today by going to mitigate, which will take you to a separate space where you can define your condition, saying if I get X number of 5xx within 1 hour, and a slow time frame, go ahead and restart. Only the instant that is bad, right? If I'm seeing this amount of requests is within so much time frame, do take an action and things along those lines. But once that comes up, you'll be able to see that. But yeah, go ahead and play around with those and let us know if there's anything that we can help with. The way you can provide feedback, again, sending the feedback to the point. You can always submit a feature request to the user voice. And some of the sessions that I would like to recommend that you come attend. There's the one that I'll be talking at 2:30 about container apps and app services, which is Linux web apps. If something that you're interested in, please come join us. And then there are a bunch of serverless functions sessions that are out there. All right, thank you.